Welcome to today's tutorial. So in this tutorial we're going to look at the basic differentiation rules. We're going to look at the basic rules of differentiation. So the first thing that I want to tell you is that don't forget to subscribe to my channel, and if you have any questions, feel free to send them over to any of these platforms. On Facebook you can use my name Harmtedy. On WhatsApp you can use this line here, which is 0960108064, and then you can also give me a direct call on my Airtel line. Then once you subscribe, make sure that you click on this button here, which is just the notification button. It will help you in the sense that anytime you want to, or anytime I post anything on my channel, it will notify you to say something has been posted on the channel. So if that thing is important to you, you'll be able to view it in no time, in just a short period of time, or you see it, at least you know to say there's something that has been posted on the channel. So it's very important. Click on that notification bar. Alright, so let's quickly look at the first principle. So the first principle, okay, so we look at the first principle. So the basic rules of differentiation, we'll look at I think there are about 5. So start with the first principle. Then from the first principle we'll look at the power rule. Then from the power rule we're going to look at we'll look at chain rule, and then after chain rule we'll look at the product, and we'll finish by quotient rule. Then we'll also maybe look at the trigonometric functions, differentiation of trig functions and log functions. Alright, so stay tuned as we solve. So let's look at the first principle. So the definition of the first principle is simply just f prime of x, which is just the same as dy dx if we're using, if the equation is in terms of x. This one is given by finding the limit when h approaches 0 of f of x plus h, and then minus f of x, then everything divided by h. Alright, so when you find any question, then you've been taught to use the first principle. This is what you're supposed to use. Let's see how you're going to do it. So for instance, if you have a question like f of x is equal to 3x squared. So how do you differentiate this using the first principle? You simply just have to find f of x plus h, and then you subtract it, the main function from that. So let us find f prime of x of this expression there. So we are simply finding the limit when h is approaching 0 of f of x plus h, means where there is x. When we say f of 1, it means that where there is x we put 1. So when we say f of x plus h is simply just the same as putting x plus h where there is where there is x there. So we have 3, and then we have x plus h there, and then it is squared there, so we square it, then minus the whole function, which is f of x, which is just the same as that 3x squared. Then everything we're dividing them by h. Right, so from there we can now find f prime of x, which is just going to be equal to, so we maintain this limit of 3x plus h squared. So we can simplify this part, which is just going to give us, so when you simplify x times x, that will give us x squared. Then when you simplify that, this will give us 2xh, and then plus h squared. Then we have minus 3x squared. Then everything divided by h. So f prime of x is equal to, then this part we can open the brackets. So we have the limit there when h is approaching 0. We open the brackets here, we're going to have 3 times x squared. This will give us 3x squared. 3 times 2xh, that will give us 6xh. Then 3 times h squared, that will give us 3h squared. Then subtract that. Then everything divided by h. So as we can see, this 3x squared and this other 3x squared can subtract to give us 0. So we can leave them there. Then we proceed by writing the remaining function. So the remaining function is simply just 6xh then plus 3h squared, and then we're dividing this by h. So this h and that h and one h there will cancel. So we just remain with f prime of x is equal to the limit of h, as h approaches 0, of x, 6x plus 3h. This is what we're going to have. So what this means is that while there's h, we're going to put 0. So whenever there's h in the function, we replace with 0. So we replace with 0 in this function while there's h. So when we put 0 while there is h on 3h there, meaning this whole part will become a 0. So let us do that. Okay, so we say 6x then plus 3 times 0 there. So our f prime of x will simply just be equal to 6x, because 3 times 0 will give us 0. So our f prime of x, which is just the derivative of f of x, will just remain as 6x. Alright, so this is the definition of differentiation. So this is how you deal with the first principle. So the most important thing on the first principle is just the definition, the formula. So the formula is the most important part of the first principle. So let us quickly move on to chain's rule. So this is how you solve all the questions using the first principle. So what you do is just find f of x plus h, and then you subtract the main function, and then you divide by h, then simplify everything, and then at the end of everything you make sure that you have you come and replace wherever you're going to remain with h, just come and put 0 there, then you find it that way. Okay, so let's quickly move on to chain's rule. Okay, so before we do chain rule, let's first look at the power rule. So the power rule is simply just okay, so the power rule states that if you have a function, let's say y is equal to ax to the power n. If you have a function y is equal to ax to the power n, to find dy dx, you just need to multiply this n times a. So you are going to have a n and then x to the power n, and then that n you subtract 1. So you're going to have this as your standard for the power rule. So for instance, if you've been given y is equal to 3x squared, so y is equal to 3x squared, to find dy dx, we said we multiply 2 times 3 there, we're going to get 6, then we write x and then raise this to the power 2, we subtract 2 minus 1, so 2 minus 1 will get 1. So this is just the same as 6x as the answer, which is exactly the same as the answer that we got in the previous example that we had on the first principle. Okay, so let us look at the other expression. We can have y is equal to maybe 5x to the power 3 minus 2x squared plus 3. So to find dy dx for this one, we differentiate them independently. So 3 times 5, that's 15, then x, 3 minus 1, that's 2. Then we have minus 2 times 3 there, 2 times 2, sorry, that is 4. Then we have x, 2 minus 1, that's 1. You can leave it like that. And then the derivative of a constant is always 0. So we have dy dx is equal to 15x squared minus 4x as the answer. So this is how you apply the power rule. So the derivative of any constant, the derivative of k is simply just 0. The derivative of any number that is just a constant is simply just 0, sorry. Okay. So we can also have maybe y is equal to 1 over x squared. They tell you to differentiate this. So we know that 1 over x squared can also be written as x to the power negative 2. So to differentiate this, we find dy dx using the power rule. Negative 2 times 1, the coefficient there is 1. Negative 2 times 1, we get negative 2. Then we have x to the power negative 2 minus 1, we get negative 3. So when you say negative 2 minus 1, we get negative 3 there. So dy dx will therefore be equal to negative 2 over x to the power 3 when you take it to the positive form of the power. So that is exactly how you differentiate everything. So let's quickly move on to the next rule. So what we are dealing with here was the power rule. So we deal now with the chains rule. So the chains rule is also very simple. It's not something that you need to even, it's not something that can even give you problems. Yeah, it's actually very simple. So the chains rule is used to differentiate composite functions. So the chain rule, this one is used to differentiate composite functions. A function that is, for instance, in the form y is equal to ax plus b and then to the power n. So this is when you have such a function, you differentiate it using the chains rule. So what does the chains rule state? So the chains rule states that dy dx in short, okay, let's do this. So this one, we called it a composite function because we know that there are it has more than one function. It has two functions. Which are these functions? So the first function, we're going to say let u be equal to the first function, which is this one, which is ax plus b, and then the next function, which is the second function, will therefore just be equal to, while there's ax plus b, you just put u there, then you raise it to the power n. So the first function is this one, the second function is this one, hence two functions. So how do you now state the chains rule? The chains rule states that dy dx is simply just equal to du dx times dy du. So when you multiply this and that, you should get back to that, because you know that this and that is going to cancel. Okay. So from there, let us now look at one example. Let's say you have y is equal to 3x and then plus 1 and then squared, or to the power, let me say to the power 4. Okay, so the first function that we have in this expression is u is equal to, so it's not really u, but you just make it u. So you say let u be equal to 3x plus 1, and then the value of y becomes while there is 3x plus 1, we put u and then to the power 4. So the first thing is that we get the first equation, which is u is equal to this one, the first equation, which is, we have this one as the second equation. So we first get the first equation, which is 3x plus 1, then we differentiate it to find du dx. So du dx will just give us 3. So the derivative of 3x is simply just 3. The derivative of a constant 1 is simply just 0. So we can just write 3. And then we also get the second function, which is the second function we have here is this one here. Y is equal to u to the power 4. So we find dy du. So dy du will simply just be equal to 4 times 1 there will give us 4. Then we write u, 4 minus 1 there will get 3. So I'm using the power rule to differentiate that. Okay, so let us now apply the chain rule. Or before we can even apply the chain rule, let us write this in terms of x naught u. So we have dy du will therefore be equal to 4. And then while there is u, we're going to put the value of u, which is this one here. The value of u is 3x plus 1. So we put 3x plus 1 while there is u. So we put 3x plus 1. Then we raise it to the power 3. Okay. So from there now, let us now apply the chain rule. States that dy dx is equal to dy du. So we can start with any, and then so dy du times dx du. So dy du times du dx. Du. So we multiply this with du dx. Okay, so this is the chain rule. Let us now plug in the values that were found. So we have dy du, which is just this value there, which is 4 3x plus 1 to the power 3. Then so we have dy du, which is 4. Then we have 3x plus 1 to the power 3. Then we're multiplying this with du dx, which is just 3. So when we multiply that, we just get the answer to be 12, open brackets, 3x plus 1 raised to the power 3. This is the answer. So this is exactly how you apply the chain rule. So the most important part to note on the chain rule is just the formula, this part. And you should always know that it only works when you have an expression that is in the form y is equal to x. This can be x to the power any power there. It can be 3, it can be 4, it can be 5, it can be 6, it can be what, I don't know, any value there. And then plus b, and then to the power any there. This n can also be any number. So if you have anything that is in this format, make sure that you equate what is in the brackets to u, and then the other function becomes y is equal to u to the power n. Then you differentiate these two functions, then you replace them there as your you replace them there. After replacing them there, you simplify the expression. This is how we got to that. Alright, so let's quickly move on to the other rule. So we've looked at the chain rule, the power rule, and the first principle. Okay, so we quickly look at the product rule. So the product rule, just from the word itself, product, this means that when you only get a product when you're multiplying two functions or two numbers. So this implies that you also have to you also need to have two functions multiplying themselves for you to use the product rule. So for instance, if you have y is equal to x to the power 3 is multiplying with maybe x plus 1 to the power 4. So when you're multiplying these two functions and then they ask you to differentiate this function, to find y prime or to find dy dx, you can use the product rule because you know that there is this first function and the second function multiplying themselves. So this rule states that dy dx is found by saying v times u prime. U prime is just the same as du dx, and then plus u dv dx. That is how you use the product rule. So some books, they represent it as v u prime plus u v prime. So this is exactly how you use the product rule. So let's take this same example here. So we're going to have, okay, let me put a squared here so that at least it becomes more interesting. So we're going to get this as our v, this one as our u. So this function, in short, is supposed to be, or rather the function that you are differentiating using the product rule, supposed to be u times v. So you can get any of these two as your u and your v. So let me say my u is equal to x to the power 3, and then my v is equal to x squared plus 1 in brackets to the power 4. So differentiating this will require us to use chains rule. This one we're going to use the power rule. So to find u prime, which is just the same as du dx, we will simply just differentiate this using the power rule. 3 times 1 we get 3, then x to the power 3 minus 1, which is 2. Then to find v prime, we're going to use the chains rule. So chains rule you can follow the same steps that I recently just showed you, but I'm going to use the shortcut here. 4 times 1 there, which is just 4, then open brackets, then we have we differentiate what is in the brackets there. When you differentiate x squared, you get 2x. Then when you differentiate 1, you get 0. So we just write 2x there. And then you write back the same expression there, which is x squared plus 1. Then raised to the power 4 minus 1, the answer is 3. So when you multiply these two, you're going to get your v prime as 4 times 2x, you get 8x. And then open brackets, we have x squared plus 1 to the power 3. Yeah, so let us now apply the product rule. So dy dx according to the product rule is simply just v u prime plus u v prime. So this now let us replace the values there. So our v is simply just this part there. This is our v. So we put v there, x squared plus 1, then everything raised to the power 4. And then our u prime is simply just 3x squared. So 3x squared. Then we say plus our in this expression our v is simply just, sorry, our u is simply just x to the power 3. So we put x to the power 3 there. Then open brackets, we have our v prime. V prime is simply just 8x. So we have 8x, and then multiplied by this, which is open brackets. We have x squared plus 1 to the power 3. X squared plus 1 to the power 3. Okay, so we can simplify this. This will just be equal to let me just write it here. Okay, so when we simplify this, we can have this 3x squared, or what we can do is we can just factorize this one is common. We can see this here is also there, so we can factorize that. So when you factorize that, we're going to have x squared plus 1 in brackets to the power 3 is common. So since it's common, we'll open the square brackets there. Yeah, so when you remove x squared plus 1 to the power 3 from this, we'll just remain with 1x squared plus 1, and then together with that, multiplied by that. In short, that's what we're going to remove, and that's what we're going to remain with. And then in this expression, everything will go there. We'll just remain with x to the power 3 times 8x. So that is, let me write that. Yeah, so I'm going to remain with 3x squared times 1 of this. So this is exactly what I've written there. And then here we'll remain with 8x times that, which is just 8x to the power 4. 8x to the power 4. That is what we're going to remain with. So there now we can simplify it further by saying x squared plus 1 in brackets raised to the power 3. Then when you multiply this and that, you're just going to get 3x to the power 4. 3x to the power 4. plus 3x squared when you open the brackets, and then you have 8x to the power 4 there. Then you close the brackets there. Okay, so we have the other thing that we have here is, okay, we can just copy them down like that. Yeah, so then here we can add this part here, 3x to the power 4 and 8x to the power 4. When we add them, we're going to get 11x to the power 4. So we can simply just write them. So we write that 3x to the power 4 plus 8x to the power 4, we get 11x to the power 4. Then we have plus 3x squared. So you have simplified your function. So this is going to be our y prime. This is the final answer. So it's also very simple. The simplification part is the one that is quite tricky, because it's the one that involves a lot of algebra. Otherwise, everything else is simple and straightforward. So the most important thing on the product rule is also just knowing the formula. So just knowing the formula of the product rule can make you get all the questions on the product rule, all the questions involving the product rule. So this part is very important. So product rule also sometimes require you to use chain rule and the power rule. So you just have to get used to all the rules of differentiation. All right. So let's quickly move on to the next. Let's quickly move on to the next question. I mean the next rule, which is the quotient rule. Yeah. So the quotient rule. Okay. So the quotient rule, just the word itself, quotient, is also telling you something there. This is a rule that is used to differentiate two functions that are dividing themselves. So if you have a function that is in the form y is equal to u over v, which is the numerator can be u, or you equate the numerator to u, the denominator to v. So you use what is called the quotient rule. The quotient rule states that dy dx, of course u and v are supposed to be functions of x if you are writing it as dy dx, but it's not always that u and v will be function of x. Sometimes they can be functions of theta or any variable. Yeah, so dy dx states that, or rather y prime is equal to you say v. For this one, v should always be the first one, v u prime minus u v prime, and then everything divided by v squared. So this one, you don't have to interchange the letters. Once you just interchange the letters, everything becomes sour, everything becomes bad. Anyway, so this one can also be written as y prime is equal to v du dx minus u dv dx, then everything divided by v squared, still the same. Alright, so let's take a look at this example here. When you have y is equal to, maybe you have x squared plus 1 over x squared minus 1. Then they ask you to differentiate this function using, sometimes they will not even tell you the rule that you use. You just have to decide on your own, looking at a function. So here we have y is equal to, let's say from this expression, our numerator will be u and our denominator will be v, and this shouldn't be changed. You don't interchange them, that your numerator is v, your denominator is u. You might end up making a mistake unless you get used to the formula. So you say let u be equal to the numerator there, which is x squared plus 1, and then v be equal to x squared minus 1. So to differentiate, we find du dx and dv dx. So du dx here will give us, du dx will simply just be 2x using the power rule. Then dv dx will simply just be equal to 2x as well. So here it's just a matter of plugging in the expressions in the formula. So the formula is dy dx. So dv dx can also be written as, sorry, du dx can also be written as u prime. Then dv dx can also be written as v prime. Okay. So this can be written as, the formula is simply just v u prime minus u v prime over v squared. So we replace the functions there. So the value of v is simply just x minus x squared minus 1, then multiplied by u prime. U prime is simply just 2x, then minus v prime. V prime is simply just 2x, and then u is simply just x squared plus 1, x squared plus 1. Then everything divided by v squared. V squared is simply, v is simply just that. So we say x squared minus 1, then squared. So we just need to simplify the expression. That's the remaining part. So 2x times x squared will give you 2x to the power 3. And then 2x times negative 1, we get negative 2x. So negative 2x is what we'll get there. And then we also have negative 2x times x cubed there. You get negative x squared, negative 2x cubed. That's what you're going to get. And then negative 2x times positive 1, you get negative 2x. And then everything divided by v squared. So we divide everything by v squared. So from there we can now just simplify the whole expression to get the final answer, to get the value of y prime. So let's just simplify. We can see that 2x cubed minus 2x cubed, that will give us a 0. Then negative 2x cubed here, and negative 2x cubed will give us negative 4x cubed. Okay, so we have y prime is equal to so this one and this one will give us a 0, and then this one here and this one there, they will give us negative 4. So you can write negative 4 there. So we have negative 4. So we have negative 4 there, and everything divided by v squared, which is x squared minus 1 squared. So this is how simple the quotient rule is. So for the quotient rule, the same thing applies. The most important thing is knowing the formula. So once you just know the formula and how to use it, then you'll never get any question concerning the quotient rule, or any question that is involving the quotient rule wrong. You'll always be getting them right. So the most important part is just knowing the formula. Remember, v should always be the one to start, and then u on the other side. The reason why we're saying you don't have to interchange them is because subtraction is not commutative. For subtraction, when you interchange two values, you simply get wrong answer. Sorry, not really wrong. It may be correct, but it will be different from the other answer that you are going to get after re-interchanging the same values. Yeah, so make sure that you don't forget to subscribe to the channel, and make sure that if you have any questions, you follow me up on one of these contacts down here, and on Facebook, that's my name. And don't forget to click on the subscription button. Then after clicking there, you see this this symbol here will appear on the right side of the subscription button. So click on that same icon as well, so that you shouldn't be missing out the things that I'll be posting, posting on the channel. Alright, thank you very much. See you in the next tutorial video. Shalom, shalom.